Okay, in this particular video, I'm going to talk to design metrics. High-level design metrics fall under one of these four categories. You talk about the structural complexity, data complexity, system complexity, or things known as the carbon glass AT. So I'll start with structural complexity, denoted by SI for a particular module I. So when you've broken down your system into a whole bunch of small modules, SI is equal to the square of the fan out of I. The fan out is the number of modules immediately subordinate or directly invoked by that particular module. And if you recall back when we were talking top down, when you're breaking down your design, we came across that fan out. Data complexity, denoted by DI for module I again, is equal to VI on the fan out of I plus 1, where VI is the number of inputs and output passed to and from I. These inputs and outputs could use V because they're variables. Those are the inputs and outputs of any one program. Say it could be global variables, or it could be parameters passed in the function parameter list. So these are not the variables that are created locally to the function alone. They're the ones that are changed as inputs and outputs to that particular function. The next particular design metric is the system complexity, or CI, is equal to the sum of the structural and the data complexities for a particular module. As each increases, the overall complexity of the architecture increases. Another metric that people use is the length multiplied by the fan in plus fan out squared, where the length is actually lines of code. The fan in is the actual number of modules that invoke a particular component. You also have metrics that are graph based, that are based on nodes and edges, modules and lines of control. Usually they might have things like the depth of a tree or the arc to node ratio. Another set of metrics that you could use are those to measure the coupling of the system. Here are four parameters. DI is the number of input data parameters. CI is the number of input control parameters. DO is the number of output data parameters, and CO is the number of output control parameters. You also have global measures, which is use GD and GC, which is the global variables for data and the global variables for control, and the environmental measures, which are denoted by W and R, which are the fan in and fan out respectively. So you can actually measure the coupling using the symbol MC, and the coupling is equal to K over N, where K is usually taken to be 1, and M is equal to the sum of DI plus ACI plus DO plus BCO plus GD plus CGC plus W plus R. Is the sum of all of the parameters you saw from before, and A, B, C, and K are actually adjusted based on data, so people can play around with that. The simplest case is you could just leave them all as 1, and you would actually end up with a value for coupling. Now you notice that M, the sum of all of these variable parameters that you pass in, the more you have there, the lower your coupling number, because it's on the denominator of that equation. In terms of cohesion, that's the function of the data objects, and coupling, which is a function of the input and output parameters, global variables, and other modules caused. You could also have the complexity of the program flow, where there are many. We went through psychomatic complexity in a previous video. Cohesion itself is actually very difficult to measure. There is one guy that I know of that is a paper in Transactions of Software Engineering, volume 20, written back in 94. You can look it up. I don't really recommend it for this course. It's just for you to know that there are such things, but it's actually kind of difficult, and I think I'd like to leave it out of the scope for this particular course. And that's pretty much it. so you will note coming out of this video, you can actually measure things related to the design, especially about the coupling and cohesion of the program, which we discussed when you were breaking it up uh, prior when we we're talking design. So that's it for this video. Bye.